the 25-ton penalty. New Glenn's landing gear assembly alone pulls 25 metric tons off the theoretical maximum payload capacity. While the industry fixates on the spectacle of a 7-meter booster returning from space, the engineering reality is a cold trade-off between structural mass and recovery reliability. This is not about being flashy. It is about building a reusable heavy-lift architecture that functions in sea states where a standard drone ship would be forced to abort. The key to this recovery is not just the rocket, but the platform waiting for it. The stabilization system on the Blue Origin landing vessel represents a massive capital bet on reducing lateral landing loads. Stabilization via jack-up mechanics. Blue Origin's landing platform utilizes a heavy-duty stabilization system to negate the heave and roll of the Atlantic. Standard barge recoveries used by competitors are limited by significant wave height, often scrubbing launches, because the landing deck is moving too fast for the booster's flight control system to track. By utilizing a platform that can actively damp sea motion, Blue Origin effectively moves the landing pad from a shifting ocean surface to a stable terrestrial equivalent surface. This stability allows for a simplified landing algorithm, but requires a massive investment in sea-based hardware that SpaceX simply bypassed. The engineering delta here is stability over simplicity. The mechanical reliability gamble. The decision to use landing legs instead of a tower-based catch system creates a permanent performance tax on every mission. SpaceX chose to move the recovery hardware to the ground to maximize the propellant-to-payload ratio. Blue Origin opted for onboard legs to decouple the booster from a hyper-complex ground-side mechanical interface. This makes the booster more autonomous during the final descent phase, but forces the BE-4 engines to fight extra dead weight during the landing burn. Think of it like a plane carrying its own runway lights and arrestor gear. It is less efficient, but it removes the single-point failure mode of a mechanical arm missing a moving target. However, it adds hundreds of potential failure points in the hydraulic deployment systems. Catching versus carrying. 6 legs provide a wider tip-over radius than the 4 used by the Falcon 9, significantly lowering the risk of a post-touchdown incident in high winds. This wider landing envelope is critical for a booster of this height and mass. Catching a rocket mid-air requires millimeter-perfect RCS and engine throttle response, leaving zero margin for aerodynamic gusts. Carrying legs allows New Glenn to absorb a less-than-perfect descent, but the cost is clear. Every kilogram of landing gear is a kilogram of satellite that stays on the ground. This reflects 2 different philosophies of risk. Blue Origin trusts their hardware to deploy, while SpaceX trusts their software to intercept. The shift toward industrial reusability. The successful sea recovery of New Glenn demonstrates that Blue Origin is prioritizing operational cadence over absolute mass efficiency. By comparing the stabilization of the jack-up platform and the heavy leg assembly, we see a deliberate move away from the mass-optimized philosophy that defined the early reusable era. This strategy assumes that the cost of carrying extra leg mass is lower than the cost of missing a catch window or scrubbing for sea states. For the heavy lift market, this means Blue Origin is trading a few tons of potential payload for a much higher probability of getting their expensive BE-4 engines back in one piece. While others chase the limit of physics by removing landing gear entirely, this platform-based approach treats the Atlantic like a predictable concrete runway. This signals a transition from experimental spaceflight to an industrial transport model where reliability is the primary design driver. The specific metric to monitor over the next 12 months will be the refurbishment duration of the engines after seawater exposure compared to the Starship turnaround cycle. Subscribe for more